confirmatory analysis using JASP, a software that is being supported and produced by University of Amsterdam. In fact, as you rightly see here, JASP is an open source project with structural support from the University of Amsterdam. It has an intuitive interface that was designed with the user in mind. So if you are more interested in performing classical and Bayesian analysis, this is the right choice for you. So here, for the first time installing the software, this is what you see. So you only need to import your data. Just click on show main menu. Click on it. Locate your data file. Here is for recent. So if you do not have, just click on my computer, browse, locate where your data file is, and you can import it. It allows for the importation of SPSS files. So you can just click on this and you open. Then you have your data sets here. So, and for the purpose of this video, we are going to talk about using the interactive phase, the interface. So you just click on factor analysis. You see exploratory factor analysis. So you click on confirmatory factor analysis. You have the chance to key in all your items. So in our data set, we have attitude towards people living with HIV/AIDS and practices towards HIV/AIDS prevention. So for the first scale is ATT and the last one is ATT 11. So just click on the first, click on this, click on this, add another one to the last one. 6, 7, 8, 9, 10, 11. So you see we have the factors here. Just label it attitude towards people living with HIV/AIDS. So we have another scale. So we'll click on this plus sign, put practices towards HIV/AIDS prevention. So we key in. So you can make it easy by clicking on the first variable, hold your command key, click on the last. I think it's not working. Just use this, hold shift, last, then you add your variable, and you are good to go. So we have the output here, and you can check the factor loadings. So you see here the estimate, that's the unstandardized loading. We need to look for the standardized loading. So we'll go to the model. Now we don't need anything here yet. Go to advanced. This Lavan, we are using Lavan. You can decide to use the M plus estimation. Auto, we can decide to choose maximum likelihood since our sample size is more than 200. So we can decide to use a Lavan package or M plus. Let's consider using M plus. So let's go to additional output. Let's consider checking chemo, Bartlett's test of sphericity. Let's look for additional measures and let's check other options. Plot, misfit plot, we can add it. And we are good to go. So let's check our output. So you see that the first thing you see is the fit indices. So we have the CFA that is 0.92 approximately, which is above 0.9 Looking at these our parameters, we can see that we have a good fit. So let's look for the RMSE is 1, 0.1 is very low, high than the recommended 0.8 or 5. Let's look at, okay, SRMR is okay. AGFI, let's see the AGFI. Okay, the estimation is not here. So let's go down. Let's check our is the Mayer origin test. The overall is 0.96, which is above 6. It means that our sample size is adequate for this analysis. So let's look at our estimates. I'm trying to see if I can get the standardized factor loadings. So good mean structure, no. Okay, we have what we call the standardization. So you do it, click off, and you wait for the estimates. So these are the standardized loadings, STDS. So you see we have good estimates. They are all above 0.5. The minimum I think is 0.698, which when you convert becomes 0.7. So approximately we can say that we have good loadings in our study. So let's go down, misfit more plot. Okay, so you see one thing I don't like about using this interface is that you do not have the chance to see. Let me see. I want to see the, okay, we have it. So you click on standardize and let me see with it. Okay, but looking at it, you see that the diagram is not that clear as compared to Jamovi, but it's good anyway. So looking at our estimates, we can say that it's good. However, we have issues with our RMSE, so we can consider deleting some items.